want you to leave this chiller training understanding how to fully test these SCR in a Viper drive assembly. I got my test board here in front of me. We're going to be going through the procedures step by step on what you need to do and how you need to do it. Hi, I'm Holden Schamberger. I'm with Chiller Academy and HVAC Time. I specialize in chiller systems. We're going to be talking about these VSD assemblies today, specifically the Viper drive assembly, which is a little bit older version. The slightly newer ones are the hyperdrives. That's the two main differences. There are some design principles that changed between the two generations. There will be future content on the hyperdrive assemblies, but we're going to focus on Viper today. In a Viper drive, we have an SCR. Now, this is going to be a cut down version of this particular lesson. There will be a full version with just a little extra detail in the YK course at chilleracademy.com. So if you go enroll in that, not only will you get the full access, you'll also get to join the Chiller community over there, share information, get troubleshooting support. We'll help you out. I'm also adding a Viper and Hyperdrive modules to that YK course. Now, starting off, there will be just a Viper drive, and I'll cover some stuff there. And as I can, I'll get to work on the Hyperdrive assemblies as well. These test procedures can be done with the SCRs in place. There's no need to remove them. We don't need to disconnect anything. They can be done as they are. It is really critical that power be completely turned off to the VSD assembly, to the whole chiller. Nothing should be powered up. And we need to make sure that the DC bus back here has fully discharged. This is full of capacitors. They're going to store some energy. That has to be discharged before we start any kind of testing. If this is not, this can create a backfeed through your meter. Stuff can get broke and you could get hurt. So please take that seriously. To verify that, you can test across this bus. You can test across the back of your IGBTs. So those will be sitting up on top of where these SCRs mount. So these mount to a cooling plate. Above that is your IGBT assembly. The back of those terminals, or if you find two terminals close together back here on the capacitor bank, you can test across your capacitor. So there's several places you can look at to see what is my current DC bus voltage. To do that, you just want to set your meter to volts DC at least a 600 volt scale. As the bleed resistors are taking the power off of the bus, you can literally sit there and watch that voltage drop. So if you wanted to just set your meter up with some clamps or something, or some alligator clip leads, you could quite literally just kind of watch it discharge. Now, if it's not discharging, then you need to check your bleed resistors. So there's something going on there, but do not do any of this testing until that bus reads a full 0. So if you have a bleed resistor problem, address that bleed resistor before proceeding any further. So getting into the readings, we're going to have our digital meter set to our diode setting, or if you're using analog, make sure you're just on a X1 scale. The very first test, we're going to go our red lead to our T1 for our SCRs, SCR1, SCR2, SCR3. Right above this is our IGBT assembly. And then these are copper bars that come around and cross over these SCRs. So you could test anywhere you wanted to on these specific bars as long as you're on the correct bus. So T1 with your black lead on the positive bus, you should see a 2 to 3 volt DC, or it could be an OL. So depending on, if I understand correctly, the internal orientation of the silicon will depend on whether or not it's one or the other. If you're using an analog, it would either be 70 ohms or OL. If you reverse your leads, it should be the other reading. So it could be 223 VDC or OL, which would be 70 ohms to infinity on an analog. Now, I do want to be very specific here. I'm not saying 0.2 to 0.3, which, doing a lot of electronics work, if you're familiar with that, that's more of what we're used to dealing with. No, these are a full 223. So you could get a 2.5, a 2.8 reading, and that would be what you're considering normal. And then as you step through this test, You're just going to go across each T1 terminal. You should get the same results across each of these. So by same results, I don't mean 2.5, 2.5. What I mean is this one may be 2.5, 2.6, 2.5 again, but you shouldn't be getting a 2.5 OL 2.6. And then when you reverse your leads, if this gives you OL, then you would want to see OL and OL. Now this next test for the negative bus gets a little different. First reading, we're going to put our black lead on T1, red lead on the negative bus. This is going to give us a 0.3 to 0.4 VDC reading. It should give you between that reading on that scale, which in ohms would be a 5 to 15 ohm value on an analog. And you would do that same test across and you would get that same result of 0.3 to 0.4. Now, when you reverse your leads, pay attention to this. When you reverse your leads, and red goes on T1, black on the negative bus, you go back to the previous results of 2, 2, 3 VDC or OL. It could be either. And then you would just take your readings across and make sure they all match. That is the test procedure to go terminal to terminal to see what the condition of the internal silicon is on these SCRs. Keep in mind, these particular SCRs are only used on the Viper drive assemblies, which is your little bit older drives. If you open it up, you might see a hyperdrive. One of the ways to tell a difference, there's several. They do look different, but we don't have these SCRs. We have IGBT modules that do our rectification coming in, and we have IGBTs doing our inversion or inverting going back out to the motor. So it's one of the things to just be aware of, and I want to be real specific on which drive assembly we're referencing here. So this does not guarantee that the SCR is fully functional and everything's okay. This just states that the internal silicon hasn't had a direct or obvious failure or internal short. Two big reasons why I'd ever need to check this in the field. One, if I am popping my fuses, something's going on. More than likely, in my experience, either one of these SCRs or this DC bus has failed. Typically, it's an SCR. By DC bus has failed, that could mean a capacitor is blown. And I've had both happen. I've opened it up, and I had two SCRs that quite literally just exploded. They're in a few different pieces. And then drilling into the drive assembly, I'll find that one or two of the capacitors also swole up. Which one took out the other? Who's to say? Not really sure. More than likely, it's probably the SCR shorting across, overloaded the DC bus, and also mixed that AC and DC together, caused a big bang, and the capacitors, got took out in the process. Very, very probable scenario. Either way, point is, if you're popping fuses or if you're having DC bus irregularities, so that the reading isn't stable or it's slightly high, a little low, just something's not quite right about it, your SCRs is where you want to start checking, and you would go through this test procedure to verify what my values are.
I want to say thank you to today's video sponsor, which is CSG, Compressor Solutions Group, based out of Houston, Texas. They've also got a shop in DFW serving the Texas area, and they also can provide you compressor service nationally. They're a great group of guys. They've done a really good job with just getting their information out there. They try to really invest into training in this industry and just supporting the contractors. Reach out to Jake with any questions you have. He'll be able to take care of you, be able to help you out. They do full service and rebuilds on screw compressors and semi-hermetic recips. They've been a great friend of the channel. They've been a great friend of mine. I look forward to working with them for a long time to come.
Just recapping this picture, your SCRs are down here at the bottom. There's two black pieces. This particular bar you're looking at, this is your positive bus. So this will be one of the test points you're measuring to. Then you've got your IGBTs on top. They're both mounted to the cooling plate. It's also referred to as a base plate. So that is the plate where we flow the cooling solution through, or the inhibitor, in order to keep those electronic components at a proper temperature. And then back here behind that, those blue things you can kind of see in that crease there, those are the big capacitors we're referencing. This is a power assembly specifically, and what I drew here was for a power assembly. And this particular one is the smaller version of the two. You could have the larger horsepower, which then breaks up into 3 IGBTs, but we still have our same input SCRs. Then on our larger horsepower systems, you're going to run into the pole assemblies, which is basically each one of these little smaller assemblies stacked one per leg of power. It'll be a slightly different orientation. These will be some stuff we talk about in the Viper and Hyperdrive modules within the YK troubleshooting and operations course at chilleracademy.com. So be looking for more of these classes and courses to come out over time. This is the kind of stuff that over time will get built out into YK. I'm trying to make sure all the basics are there. I'm also building the Introduction to Chillers course, which is making a lot of progress on. So if you'd like to just get into chillers, get started, and you're struggling to understand basic terminology, basic readings, how things work, you're sitting there looking at the thing and you just can't really get your head around what's happening inside of that chiller, that's the best place for you to go. Is Introduction to Chillers. We're going to cover all of the basic essentials, all the terminology, all the mechanics that you need to know in order to just approach these machines and have an understanding of what it is that you're looking at and what you would expect to have happen. By understanding the operations and principles, you should have an expectation of what it's going to do. Once I'm finished with the introduction course completely, then we will start to refocus and fully build out this YK. We'll get into some CVH courses, and we'll continue this knowledge train to give you the material and the support that you need to do this as successfully as possible. With that, MTT, make the time for your family, for your spouse, for your kids. They really need you around. I'll see you later.